You have out on your desk your note packets. In general, a good rule of thumb is, well, we'll say it this way. Have your note packets out, open to where we left out before. You all need to understand that there are going to be calculator permitted and calculator free sections. One of the things that I can't tell you how the calculator is supposed to be used to like extend what you're doing. So like if you've got 4.83 times 7.86 to the third power, that's going to be something that you would be expected to use the calculator for. But the part that gets frustrating for me is like sometimes on an assessment, you'll see, I'll be like, all right, we need to take 10 plus 4, who can tell me what that is? And then I'll look over and I'll see, that's not what it's for. That's the part that scares me, is that, there's some math that's very manageable in your head and some that's challenging. If I give you an assessment, though, that's non-calculator active, you've got to be able to go through and answer some of those without it. Unlike today, the calculator really wasn't going to help you that much anyways. The other end of it is on your exam, though. I think I told you this, that there's a calculator page and a calculator free page. Is that right? Okay, I think there's like 6 questions on each page. They're all weighted about the same. Obviously, the longer and more complicated questions are going to get a couple more points. But what you all need to understand is and anticipate that. And the other thing is a little bit of time management, because obviously part of the exam you're going to start off with without the calculator. And then when you hand that sheet in, you're going to pick up your second sheet, which is calculator active. If you spend 40 minutes on the non-calculator page, and that leaves you 10 minutes on the other one, it's America. You've just made a profound choice. But it's not going to leave you a lot of time. You don't get extra time because you took it. Again, the test is designed actually to be done in 30 minutes, not 55. So actually you're all getting time and a half every single time. It's not a lot, so understand that we're expecting you to really hit it out of the park on the questions that we have. Now, and I am so ancient that I will be the first to admit I don't know how these calculators work exactly, so you'll see me stumble constantly over whether we hit dock or menu. One thing that you all, and go through and sign into your calcs now, one thing too that you're going to notice, and I hopefully say it enough, I say it to remind myself, this question is menu, document based and menu driven. So that means your template, your big picture stuff, your new problems are going to occur by document. The functions themselves are accessed through the menu. That's why, notice, I don't sit there. You probably had teachers before who sat there and banged on the screen. You're used to hearing, because they smash the buttons on the calculator, right? How many times have I done that? I'll pick one of you to be our showcase model when we're going through and doing it. I'm terrible at them. This is one of the examples today where I think not having the calculator is a heck of a lot easier than having it, because you're going to see one example that we do. The calculator is going to give you, not intentionally, but there's certain functionality limits on it. So your calculator, it's going to be more complicated to use the calculator than to not. Today, let's say this. Who remembers? There's 3 main ideas that we need to know about functions. Sorry, not functions. What did we do last class? Hands up, please, if you can tell me how I would take the inverse of a collection of points. Hands up, please, if you can tell me how I would take the inverse of a collection of points. What do you say? Yeah, you switch or transpose the x and y. So if it's a point, you switch the x and the y. How about if there's a graph? Hands up, please, if you can tell me how I can take the inverse of a graph. Reflect it over the line y equals x. And just so we're all on the same page, what does the line y equals x look like? Yeah, it's a line with a slope of 1 and a y-intercept of 0. It's regularly our positive slope diagonal. What if I have to take the inverse of an equation? Hands up, please, if you can tell me how I would do that. 2 people, 3. Oh, come on. but yesterday it didn't happen. What do you want to say?
Switch the line axis and solve the y.
Terrific. You switch the x and y and solve for y. Sometimes it gives you f of x. You change the f of x to a y equals. There's one other thing. How can I tell whether or not the inverse of a function will be a function without finding what the inverse is? How can I tell if the inverse of a function will be a function without finding out what that inverse actually is?
As long as the function fences the horizontal line and the vertical line.
What's that called? Does anybody remember the property? One-to-one function. That's terrific. Is there a lot to have? Absolutely. Absolutely. There's a ton. But if we start now, and I'll boil it down to its simplest parts, we should do terrific. This was one of the calendar questions that you had. It said graph this and use it to determine the domain on which the inverse is a function. So if we're looking to make the inverse a function, what is that really asking us to go through and have? Or our function is going to need to be what? So the inverse will be a function. Hands up, please, if you can tell me. We seriously have two people? You just answered this question. That's what this is. It has to be one-to-one. So go over to your calculators, please, and let's go in and make a new graph. By the way, easy way to tell whether or not you are in the right. I did this to the calculus students yesterday during their first exam, which was wonderful. So if your graph just went away, that's because you were graphing in the wrong part. Now, go in and let's graph out that equation, which was y equals 2x squared and plus 8x minus 7. So go in and graph that out. 2x squared plus 8x minus 7. There's one from the homework last night. Oh, hang on. Whichever one, this one we got to go back up. So 2x squared plus 8x, let me just double check, plus 7, was that it? Minus 7, less. Now, I can't go through and see where my y-intercept is going to be. So, how can I go, where is the y-intercept? It's somewhere down here. I just need to look a little bit lower. Now, most of the time I tell you to stay away from zooms. Let's try this. Go into menu. Let's try a zoom. So, window. And you can just press the buttons on these. Try A for zoom fit. Bless you. Try A for zoom fit. Is that going to give us a clearer window? Okay, so we can kind of see. Now, is this right now one-to-one? No. What do I have to find in order to get it to be one-to-one? We need to find the lowest point that the graph reaches. And if you say do a table, you might as well kick me in the face. Let's go in. How can I figure out what this lowest point is going to be? Go into menu. We're going to analyze the graph, which is 6. Am I looking to try to find a maximum or a minimum? Which one? Minimum, all right, so we'll select 2. Now, what you're going to do is go somewhere to the left of the minimum, so maybe in this region over here. So move your cursor, and you can do it just a little. I think you can hit the left arrow a bunch of times, and then go someplace to the right of that. Now, so get over past it to the right-hand side. Good stuff. Who's got it? Oh, some of these are missing axes. Once you're to the left of it and to the right of it, you create sort of a window for it to look at, and you press enter. And it's going to tell you where your minimum is going to be. When you do that, now, here's another thing. If I'm trying to figure out what this coordinate is, if you put your center, or put your finger on this here and just move it around a little bit, it activates that as a sensor. And you can go and grab it by hitting enter when there's a little grabby hand over it, like a little claw. Grab it, and then you can arrow up, and it moves the point around. So, what's the lowest value that it reaches? Or sorry, where does it, make sure this is a calculus thing. Where does it reach its lowest value? Hands up if you can answer that. Where does it reach its lowest value? That gave me too much. At -2. What is its lowest value? -15. So where does it reach its lowest value is the x. What is the lowest value is the y. Looking at this, what domain could I restrict this over such that it's going to be 1-to-1? Hands up, please, if you can tell me. There's more than one acceptable answer for this. There's two. What do you want to say? -2 to positive infinity. Or, who can tell me another window that I could look at? So this would be 1-to-1. Who can tell me why those are the windows that I picked? So hang on, we got this. Why would I want to go through and put my break here? What's the point of that? Yeah. If I'm only looking from here over, is this half of the parabola 1-to-1? What about over here? Is this half of the parabola 1-to-1? Is the whole thing 1-to-1? No. Okay? Now, let's go forward. And here's our notes for today. We're working with piecewise functions. We may go fast today because allegedly you did this in freshman L. Piecewise functions. The y is defined differently for different parts of the x. The y is defined differently for different parts of the x. View it as a bunch of graphs happening on the same surface, but one stops and then one starts. Let's go over, please, and look at this example here. If I did this example out, I look at my piecewise function, and there's an area where I transition from this top piece, which I will have in yellow, to this bottom green piece. At what x value am I transitioning? Hands up, please, if we can answer that. Where or at what x value does this transition occur? When am I going from one piece to the other? Sabrina, what do you say? Perfect. If it's above -2, I'm using the green value or the green section of the graph or the bottom piece. If it is below -2, I would use the yellow piece. So which piece would I use if my input was 4? Hands up, please, if you can tell me that. If my input was 4, which piece would I be using? Would I use the top piece or the bottom piece if my input was a 4? It gives you the directions right on it, which one you'd use. Go ahead.
Oh, bottom one.
You'd use the bottom one? Who can give me an input that would make me use the top yellow piece? What's an example input that we would have if I say, yeah, I'm graphing out that top yellow piece? -2 works? Who can give me another one? -3. Who can give me another one? -4. Anything less than -2. So when I give these graphs out, you see how I extend it? Because this would be if I had graphed them both. I use this yellow piece here, which is a line, when the x's are less than -2. I use this green piece here when it's above -2. Where am I transitioning at? Well, the transition is going to happen here, at the -2. That's my boundary. One side is one graph, the other side is another. Sometimes we have 3. Understand this when we do this out as well. You will be graphing these out, and I always ask you to first look at the function and identify the transition values. We're going to indicate it with a very lightly done dash on there. And most of the times, I'm literally going to say, instead of going to the calculator, and some of you should just marry these calculators, we love them so much, just plug numbers in. Because we just did a perfect analysis of it. I said, give me 3 values that would make me use the yellow piece. All right, I can get a good, reasonable graph from that. How about from the green one? Well, I know that the green value said we use it 3 or 4, something like that. Now let's answer this. What's the domain of this graph going to be? Take a look at the picture. What would the domain of this graph be? Ben, what do you say?
The entire thing.
Yep, for based on this complete graph, what's its domain? Because every x value is used. Sean K, what do you say for the range?
Or could it be positive?
Sure. Absolutely. It's unbounded below and unbounded above. There's no maximum value. It rises and falls forever. We're going to graph this piecewise function and state its domain and range. Now, I'm going to ask this piece of you first. Hands up, please, if you can tell me where I'm transitioning from the yellow piece to the green piece. Hands up, please, you can tell me where, at what x value, or where am I transitioning from the yellow piece to the green piece? We got 3 of us, 4. Have you ruined someone's day before? Okay. Let's have that happen today. Mickey, what do you say? Yeah. At what x value do you switch from the top function to the bottom one? 1. So I'm going to go through, and on my graph, I'm going to really lightly put a 1 here. Real faintly, I'm going to put a 1. Now, to the left of it, I'm graphing the yellow. To the right of it, I'm graphing the green. I love tables of values, so that's what we're going to use. I'm going to give out an x and a y. Now, keep in mind, there's a transition that's happening at 1. So I'm going to have to use that twice. One gets a closed circle, and the other gets an open circle. So, what x is, who can tell me an x value I would be using if I was graphing out the yellow piece? What's an x value that you'd say, yep, when I do that, that means I'm graphing out the yellow part? 0, who can give me another one? 1, who can give me another one? All right, so I'm going to go through, and it's my negatives. I'll do -2, -1, 0, and 1. Now, maybe you'll do this so you indicate there's a transition. There, I'm going to go 1, 2, 3, 4, and I'm going to stop at 5 in this example. Can anybody tell me why I would stop at 5 in this example? Why would I stop at 5 in this example? Yeah, look at the directions for when you're graphing the green. It's from -1 to 5. So I'd include 1 to 5. Now, let's plug in -2, and this again, I love. We should not need our calculators for this class. When I plug a -2 into that yellow piece, Amanda P., what would you get as your output? What do I get when I plug a -1 in? Sean L? When I plug a 0 in, Riley? Now this is where the transition value occurs. You're going to evaluate both functions at the transition value always. So when I plug a 1 into that yellow function, Marissa T., what value is that going to give you? Now, at 3, am I putting a closed circle or an open circle? Can anybody tell me why this 3, and I'll indicate it by doing that, why would the 3 get a closed circle? In the inequality, it's equal to. Now I'm going to bounce down. I'm going to plug a 1 into the green function. Anthony, what do you get when you plug a 1 into the green function? Would I have an open or closed circle at this value? Because this is up to but not inclusive of. How about when I plug in a 2? Nick, what would your output be?
-2.
And then we'd have -3, -4, -5, and so on. So when I do this out, understand, these are just ordered pairs. By the way, -2, 0 would be here. -1, 1, 0, 2. And then 1, 3 gets it closed. Now, this is a line. Can you continue that out? Sure. We've got enough at the slope of -1. We don't need to list out a table. Continue what the trend is. Again, if the points fit, give them a graph. And we said this was the one with the close. Is that right? Use something nice and flat to help yourself give out a beautiful graph. Some of you get by with these. It's terrible. Looks like you're getting punched in the face while you're trying to do a graph. Next one up, I've got 1, -1. So I'm going to go to point 1, -1, which is down here. And I'm going to put an open circle there. And then I've got 2, -2, and so on. So I drop these down. Again, I've got enough information that I continue this graph forever. Oh, now, as I have it now, I'm an idiot. You should be outraged, simultaneously outraged and offended at what I just showed you. Who, raise your hand right now if you are outraged and offended at me. Terrific. I can see this face. Why are you so outraged? Now, I'm going to list this out, and I'm going to go up to 5, and I'm going to say, all right, I'm good. And you're still outraged. Oh, that's good. Terrific. Terrific. Now, that's what our graph looks like. Was that tough? No. What's our domain on this going to be? Look at what's there. You can look at the interval or the graph. Megan B., what do you say our domain would be? -infinity to 5. Do I put a bracket or parentheses at the 5? Because it goes up to and doesn't include it. That's terrific. And Sam, what's our range on this going to be? By the way, another thing that you all do, I start getting this hybrid. You don't know what that is? There's one guarantee of what it is. It's called a wrong, right? That's when you're not being decisive. The corners should be at like a 90-degree angle, make them quite pronounced, because we always have people come in and go, well, what is this? Well, what is this? Is this a bracket or parentheses? There's been times when there was actually one day in class to illustrate how terrible some of them were. I actually took, and we did, there's an app that I have, I think I sent it to you before, where I could poll people very quickly. So the kids at U of R walked in, and I put one up, and I said, is this a bracket or parentheses? And it was a yes or a no. And we had 10 of those. So the class voted as to whether or not it was a bracket or parentheses to see what I have to go through. And it was even, the thing that was more terrific was, they were almost always like 50-50, 60-40. You know. Make it definitive, please, when you give them out. Now, next one up is a little bit more interesting. We're going to graph this. Again, we're not using the calculator. How many transition areas does this example have? Hands up, please, and tell me how many transitions this is going to have. Hands up, please, if you can tell me one of the 2 inputs where this graph is transitioning. Just tell me one of the 2 inputs where it's transitioning. -5 is one of them. So I go through and sketch a very lightly done, it's only there for a guideline and to help you. It's not part of the actual graph. Who can give me where the other one is going to be? That's terrific. Now, the next thing that I would go through and do is this. I've got to ask myself, when am I using these different pieces? So this top piece here, I'm going to use at one region, this at another, and this at another, right? So when I'm doing this, I go through and say, let's take some inputs, get an output from that. Looking at what I have, and let's list out an X and a Y. Well, actually, I'm going to say this. Maybe we can do part of this in our head. What's the graph of this yellow piece going to look like? Or everything less than 5, what would that be? AJ? So horizontal line at 4. Oh, so we're going to go to 4, plot out the point. It's always going to be 4. Now, AJ, at the transition value, is this going to be an open circle or a closed one? So this is one of the pieces. Now I have my middle piece, which is the absolute value of x, then added by, or add 2 to it. So this one I would list out sort of a table of values here. Oh. So it's -5. This one you're going to struggle with, and it's fine. So we get to here. When I have a -5 there, who can tell me what the output's going to be if I'm trying to graph out that middle green function? What's your output when you're plugging -5 into that green function? Is that one person, 2? Okay, what do you say? What's the absolute value of -5 plus 2? Now look what do you get when you plug in a -4? Oh, by the way, is this point, Michaela, would this be an open or closed circle? Why? Because it includes it. Now, let's keep going. Does anybody know what the slope of this absolute value graph is going to be? 1. Yeah, the rise over right, I guess, would be 1 or -1. Okay. When I plug in a -3, I get out a 5, then a 4, then a 3 here, then a 2, and then I would start going back up. This would be 3 and 4. So my minimum occurs here. So as of right now, and I probably walk away from this, and you all, because your little sheet would go through and say, "I'll leave it to her." Who is outraged and offended at me right now? One person, 2. The anger should be palpable. I can see you're probably. Some of you may even be ready to pick up your desk and throw it at me at this point. You're so outraged. Riley's at your level of outrage right now. Do I have to get nervous when you throwing your desk at me? Maybe? Okay. What's wrong with what's up there?
It had an open circle at 5.
Oh. Not it?
I would like it 3.
At 3. Yeah. Now let's continue this out. Here's my next one. I can finish this off, and this is going to be a line. The slope is 2x minus 1. And this happens at 3. So when I do this, I plug in a 3, a 4, a 5, and so on. When I plug in, and you could have gotten 3, 5 here, and gotten the open circle. This one here, when I plug a 3 in, you got 2 times 3 minus 1, which would be 5. Again, and this would be open. It's got a slope of 2, so go up 2 over 1. So that would be what the rest of this, you could get it from a table or not. Yes, because at 3, am I graphing either one of those pieces? No. So let's look at what's there. What's our domain on this going to be? And this is a tough one. Corey, what do you say?
Negative infinity. Would you have to jump?
What value might
be to -5?
Careful. What value is the value you have to jump over, or is not? Let's answer that first. What value is not included in the domain? Because you said it would be 1 at -5. Is -5 used in this graph?
Yes.
Okay. What value is not used in this graph, if any? There's one that's not. It's tricky. You know what I'm saying?
3. Oh.
So knowing that, how would you give out your domain if it's everything, but we have to jump over through?
Negative infinity, comma 3, then using it in U, and then 3, comma positive infinity.
How about our range on this graph? Hands up, please, if you can tell me what your range on this graph would be. This is another one, it's a little tricky. Connor L., what do you say?
2 with positive infinity.
Bracket or parentheses at the 2. One that somebody brought up was, they go, well, wait a minute, isn't 5 not included in the range? And if I'm only looking in this half, you're right. Is 5 used somewhere on this graph? Right there. Now, when we do these out, this is when you're going to go over to your calculator. One way of doing it is you're going to find the problem with using the calculator. Let's bounce over, go to our home screen, so go to on. Let's go to our home screen and go to on. Oh, now, what I'm going to actually do is this. Let's go back to, hit 4 for your current document. I'm going to show you how to not always have to go back and make a new page. What we need to do is we're doing a new, hopefully we're all in agreement. We are moving on to a new problem. So, instead of going through and constantly resetting the calculator, one way to just open up a new problem, which is different. Notice the index here. See how it's 1.1? A new problem is going to be 2.1. So we're going to open up 2.1, and I believe I know how to do this. Go into Doc. Go down to Insert, which is 4. And we need to insert a new problem. Now, which one do you think you're going to pick if we're doing a new problem? 1, yeah. So hit that. Notice the tab at the top says 2.1 now. So that just makes it so you don't have to constantly go back to that home screen, erase everything, blah, blah, blah. Now, let's go to a new problem. And to graph out a piecewise function, we're going to go to 2, which is add graphs. Now, in here, there's 2 things that you are going to, if you haven't discovered them yet, there's 2 really important things. This is a template feature, and this is where you find the inequality signs and greater than, less than, and stuff like that. So we need to go to our templates, or our form. So go press this button here. Now, a piecewise function that we're going to select would be this one here, because we're going to have to input, and I believe, isn't the one that we're working with have 4 pieces, is that right? Okay. So go through and select, not that one, the one over that's got 3, because I think it asks you how many pieces then that you have. So hit enter on that. Oh, hang on, we got to delete what's there, because we need to go through and read. Yeah, we need to go in, because doesn't ours have 4 pieces? Yeah. Okay. So go in, go to the template again, and let's go select that one, and we'll make sure you put 4 for the pieces. And the first piece, as defined in this problem, is 4 minus x. So you put that in there. And then the next thing, so you type in 4 minus x. And then to the right, you're going to put when you use it. So you're going to arrow over to the right, and then you use that when x is going to be less than. So I'd hit x. And then to get those other signals, you hit Control equals, and you select the right one. So x is less than 2. And now you're going to continue that out. Less than negative 2, I'm sorry. Okay. So now you're going to continue this out and plug the rest of those pieces in. And we're going to look at a graph, and these graphs, again, are terrific to get a generalization, but you have to be smarter than class. So go through and finish inputting all of that graph. Now, once you're done, that's what it looks like. When this is done, whomever this is, can you go through, please, and grab this function and slide it over in this region here, because there's something. Hang on. Oh. Enter when it's clawed on it. Oh. Who's able to go through? Oh, is that it? No, that's going to move the paper. Okay. Let me find a different one. Is anybody able to move theirs over? Okay, some of you are having success. Once it looks like, and it's very sensitive, once it has the open hand like this, like it's going to chomp on it, you grab it and move it over. Because there's something in here that you're not going to inherently see. So once we grab that and move it over to the side, now, here's what our graph looks like. Already I'm sitting there going, there's something missing from this graph. Hands up, please, if you can tell me. If I'm looking at this graph and look at the function, does anybody see what's wrong with this or what's missing? And look at what's there, because this graph, I mean, the computer will do it right, but it's also, the way you're looking at it is wrong. We got one person who sees an error. There's actually two errors in this graph relating to the same concept. We got three of you who can tell me the mistake. What's there?
Doesn't show the closed or open circle.
Where would there be an open circle on this graph? Can anybody tell me? Where would there be an open circle we don't see? Right here, if I did this out and this was wholly correct, so if I did this, so here's my graph. So if this was actually true, there would be an open circle here. There's something else that's missing on this graph. Does anybody see what else would be missing on this graph that you don't see right now? It's very easy for you to get outraged and offended at me, not at Texas. Yeah. 3 people, 4, 5. That's it.
It doesn't show -3
When x equals 2, the y value is -3. Is that point on the graph? Mm-mm. So are there some, now you get it from the table, but again, it's only 1 pixel wide. Not even. So the calculator is going to just jump over it. It'll show it to you in the table, but again, so do you see why there's limitations on this? Hopefully so. I want us to bounce forward a second before we do, let's take a look at this one here. We're going to write a piecewise function based on this graph. How many pieces are there in 6? Hands up, please, if we can answer that. How many pieces are there in 6? 2. So I'm going to label this one here is yellow and this one here is green. So to list it out, I would say f of x is equal to, and give myself space for 2 different, in this case we're lucky because they're lines. When am I graphing this green section? When would I be graphing that green line? Hands up, please, if you can tell me. What inputs would force me to use that? You've got 1, 2, you can give it as an inequality. Yes. Right, yeah. So we're going to use this when x is less than or equal to -1. And that means I'm going to use the other piece when? Hands up, please, if you can fill in what the other piece, when the other piece is used. X is greater than -1. Now, you need to give the equation of this line. Remember, f of x is the same as y equals. What is the slope of the line or what is the slope, I guess, of our green line? Hands up, please, if you can tell me that. What would the slope be of our green line? Seriously? Did you rise over the line? You have to be able to generate the equation of the line. You've got one person, two. You need to be able to tell me, rise over right, what's the slope of that line? 3, 4. Thomas, what do you say? 1. No? Close. What do you say? -1. So it's -1x or -x. And what would the y-intercept on that line be? Extend it out. What would your y-intercept be? If this continued,
Or it would be 3.
so that's the first piece. It's y equals mx plus b. You love y equals mx plus b. Now let's look at the other piece. Who can tell me, please, what the equation of the other piece would be? I can get it just from looking at it. It should take 2, maybe 3 seconds. How'd you get that so quick?
Well, I did rise over right, so slope is 1.
Terrific.
X, and the y-intercept.
Goodness. Outstanding. Easy. How many pieces are there in B? Hands up if you can get that. How many pieces would we have in B? 3. Who can tell me when I'm using, or when I'd be graphing? I like to go from left to right. When would I be graphing the yellow piece? Hands up, please, if you can answer that. When am I graphing the yellow piece, or what is the domain of the yellow portion of this line? Emily, what do you think? Good. Now I'm going to give it out as a little kid inequality, so I'd say x has to be Now, you shouldn't stammer with what the equation of that line is. Does anybody know what the yellow piece would be represented if I was just graphing the yellow piece the whole time? What's the equation of that yellow line? What's that? Y is equal to -2. Remember y equals goes side to side? I had Welker in my room the other day. I was showing him the little trick. Remember y equals goes side to side. The x is what goes up and down. How about the equation of this little bit here? Oh, sorry. What is the domain, or when am I graphing the green region? Hands up, please, if you can tell me. When am I graphing the green region? We've got one person that can tell me. So I'd say my x has to be between -2 and, is that right, 4? Now I'm going to leave this. I definitely can't put a line here. That's not equal to that because I made it equal up here. Over here, I could put that if I wanted to. If I wanted to. Who can tell me what the equation of the green line is going to be? So just x. And how can I finish this off? You finish this off right now. You finish this off right now. What's the third blue piece of this graph going to look like? We've got no takers. Careful. Greater than.
Oh, greater than.
Or equal to 4. And what are you graphing then? Perfect. So now you just came up with your own piecewise. Let's go back. Here's one, too, that comes up frequently. The calculus, or the AP calculus, this comes up the very first day. How could I express this graph as a piecewise function? Well, how many pieces are there on this graph? 2. And I'll tell you right now, here's what your graph would look like. This is, I went through previously and graphed this out. It shouldn't be on your paper already. you would maybe want to sketch that out so you can see what it is we're talking about. And this we did go back to find what, page 17. Is that right? 27, sorry, 27. Now, looking at what's there, when am I graphing the yellow piece of this graph? Hands up, please, if you can tell me. When would I be graphing the yellow piece of this graph? And if you get stuck, you're saying, I can't see that part. Look at the equation itself. Where do you think the pivot happens? So I say, here's f of x is equal to, I have two pieces. I'm graphing the yellow one when the x is less than 4. I'm graphing the other one when x is greater than 4 or equal to. You can put the equal to on either one. What's the equation of the yellow line? Hands up if you can say that. What's the equation of that yellow piece going to be? Yeah. Negative x plus 4. What do we think our equation here would be? If you needed to keep tracking, follow the slope to deduce your y-intercept. Remember, all you're doing is extrapolating the graph out like this. So if this continued, you can easily tell, hopefully easily tell its slope and its y-intercept. What would that other piece be? All you have to do is identify, and this is in general, identify where the original is going to pivot, which in this case is where it's equal to 0. The argument of the absolute value is equal to 0, which would be here, at x is equal to 4. And then you take the original and the negation of the original. Negation means that you multiply the whole thing by -1, but that's how those equations are arrived at algebraically. All right? Now, you have homework from your little packet. The other thing that we will say to you, and I'm terrible at it, and you can yell at me and swear all you'd like, I have so many assessments for you that need to go back. So, what we'll do is this. Let's see. Can you hand some of these out quickly? Can you hand some out quickly? Set them on their desks. I'm sorry. Please keep reminding me that they need to get handed in, because I'm bad at it. There's some group work in there as well. If the person's not here, there's bins over on the side. Go through and quickly hand those guys out. Your homework is from the packet. Whatever our calendar problems were. Yeah, if they're not here, just put them. There's a bin over on the side that says Enriched 2. Can you hand those back for me? Thank you. Yes. That's your son. Thank you very much.
Where do you sit?
Don't.